Okay, we made it last day of the week, last class, 9.3. All right, here's your homework. So this is making this the Friday before the week even begins. Actually, no, today's Saturday, so I'm making this on Saturday. Just want to say you're doing a good job getting your homework. Thanks for not being lazy. Remember, we can go at a comfortable pace, though not a slow pace, but we can go at a comfortable pace. If there's any time you ever need to take a break in order to do a review and you're like, I'm not really confident I got that class, we can absolutely take a review day. We are on track to definitely make it through before the end of May. Okay, arcs and central angles is where we're at today. It's another one of those lessons with lots and lots and lots and lots and lots of definitions. Again. All right. Okay, so here we go. Think about this. We've got a circle, have the center of the circle. I just made a central angle. You remember that. And now let's think about this central angle. Now, this central angle, which is made from two segments that come from the center of the circle, and the angle formed is a part of the entire circle. Imagine a circle with 360 degrees. You've just cut off a portion of it. So a central angle is an angle in a circle with its vertex at the center of the circle. All right, cool. So the central angle. So there is a central angle right there. I just want to make sure you understand the importance of this is that it must be at the center. In this chapter, we will learn of three other types of angles. Not today, just central angle is all we're doing today, but three other types of angles. That one's a central angle. This one is not. This is in about 2 class periods. We'll learn about that angle. That gets a special name. We'll learn about that angle. That gets a special name. And I didn't draw one, the third type, but the third type is where the center of the angle is inside the circle, just not at the center. All right, so today we're doing the ones on the left. The ones on the right are not central angles. All right, an interesting thing occurs when you have a central angle. So let me draw a central angle. The central angle, we say, cuts a portion of the circle. Now, even though, just to make it nice to look at, I made my circle with a blue inside. The blue is not part of the circle. The circle is only the round black portion. However, the central angle, the two arms that come off the angle, or the two arms that form the angle, actually intersect the circle. And where they intersect the circle, they cut off, we say they cut off a portion of the circle. So that red right there is the portion of the circle that the central angle, by its nature, by how it's constructed, it's what it forms. It forms that little piece part of the circle. And that's going to get a name. All right, so clearly the central angle, if it intersects the circle, would have to intersect at a point. So on the left side, or the arm on the left would be point Y, the arm on the right would be point Z. And so we form this curved shape. We'll name YZ, and it gets a special name. And you may or may not know this name. It's pretty common. However, it is one of the few times where we actually picked a really good word to describe it. This is called the portion of the circle formed by the central angle. So that red portion right there is called an arc. And the only definition of an arc, it's a part of a circle. And remember, the circle isn't the center. It's not the outside. It's just the round black portion. So if you take a part of that, the red part right there, you've got what's called an arc. All right, arcs come in 3 flavors. As always, here are the first 2 flavors. If the arc is less than 180 degrees, we call it a minor arc. All right, that makes sense. It's smaller than 180. We have a symbol for arc. The symbol for an arc is an arc. Put the arc over the 2 letters, and that is arc YZ, or minor arc YZ. All minor arcs are less than 180 degrees. Remember, 360 degrees would be a full circle. So that's flavor number 1, minor arcs. Now, think about point Y and Z. There was no reason we had to go from Y to Z in that direction. We could have gone to Y to Z in the other direction, and that would be an arc that's greater than 180 degrees. However, there would be some confusion if we named it the same thing, YZ. So therefore, for the next type of arc, the arcs that are bigger than 180 degrees, we add another point, or we require them to have a third point. So this arc YWZ or ZWY, either one is, since it's greater than 180, is called a major arc. So a major arc is an arc, so it's going to have 3 letters, the same arc symbol. It's just going to be greater than 180 degrees. And it could be any angle up to, no, it's got to be less than 360, but it will be greater than 180 degrees. So I said arcs come in 3 flavors. Well, there's 2, major and minor. Minor have 2 letters, majors have 3 letters. And so the third and final one is not even called an arc, although it is. It's called half of a circle. We call that, you've heard this before, it's called a semicircle. So a semicircle is an arc that is exactly 180 degrees. And once again, we have a problem. We can't call it semicircle YZ. We wouldn't know if that means go over the top or go over the bottom. So we add a third point. Semicircles will also have 3 points and the arc symbol. All right, so there's your 3 flavors: minor, major, and semicircle. So it turns out there is a relationship between the central angle and the arc that it makes, including semicircles. And it turns out, well, let's think this through. So if a central angle cuts off a portion of the circle, well, it turns out that the portion of the circle that it cuts off is exactly the same as the central angle. Think about it. If the angle is 360 degrees, then it would be the entire circle. If the central angle is 180 degrees, a straight long, that would be a diameter. Then the arc that it cuts off will be 180 degrees. And it turns out that the central angle and the arc that it makes or forms are exactly one and the same. And we are going to say that the measurement of the arc in terms of degrees is equal to the central angle. So no crazy formulas. If you got the central angle, you have the measurement of the arc, or we say arc measure. So it's an easy relationship. It's got a bad name to it. And the only reason it has a bad name is because eventually, end of the chapter, we're going to get a formula for what's called arc distance. And arc distance is the actual physical measurement. Hey, how many inches is it? How many centimeters? But when we measure the arc in degrees, how much of the circle it is, we give it the name, and I'm just going to say I don't think it's a great name. We call it the measure of the arc, or arc measure. Now, it's a perfectly fine name in terms of what I just told you. It's just that students typically, when you're first learning this, mistake arc measure and arc distance. So we won't talk about arc distance for a week or so, but the measurement of the arc is where we're going to live for the next couple of days. So the definition of the measure of an arc, or arc measure, it's measured in degrees and equal to the measure of the central angle that defines it. So if you look at the circle right there, we have a minor arc YZ, and its central angle is 50 degrees. So the arc measure is 50 degrees. Wow, if only all math could be that easy. So for minor arcs, it's really easy. But for major arcs, well, major arcs will be, for their measurement, will be defined in terms of how it's formed. Well, this one would be formed with the same legs of that angle. So if I connect O to Y and O to Z, you get a central angle of 50 degrees, but that's not the major arc. The major arc would be 360 degrees minus the minor arc. So the major arc there, arc YWZ, would be 310 degrees. And you're like, well, that's confusing. Why don't they just say 310 degrees? It's just easier to name it with the minor arc. So major arcs, their arc measure, when they ask you to calculate it, will always be done in terms of the minor arc that forms the major arc. I hope that made sense. Lastly, the easy one, well, if it's a semicircle, all semicircles have an arc measure of 180 degrees. Okay, so most people like that. It's pretty simple. Hey, the measure of the arc is the measure of the central angle, or the measure of the central angle is the measure of arc, as long as it's not the major arc. And if it's a major arc, it's just 360 minus the minor. All right, some more definitions. So if we have 2 arcs that share a common point, no overlap is allowed, but they share a common point, for instance, arc YX and arc XZ. So if I tell you YX, then the adjacent arc to it will be arc XZ. So what shares a common point with YX? Well, arc XZ, right? But there's more than just XZ. Well, that's a minor arc. Well, we could have equally said arc XZP, or any other type of arc that shares any single point in common with arc YX. If I want to go in the other direction, then arc YP or arc YPZ, or even arc YPX. All of these are all arcs that are adjacent to arc YX. All right, so why are we doing that? Well, remember, kind of sounds like what we did in chapter 1. We first started talking about segments. We talked about, forgot I put that in. We had the segment addition postulate, we had the angle addition postulate, and now that since we have arcs, we're going to have, that's right, the arc addition postulate. We haven't had a postulate in a long time. So postulate 16 simply states that if you want to know how long the measure of a larger arc, you break it up into little pieces, right? So in other words, mark the measure, the little m for measure, the measurement of arc YXZ would be equal to the measure of arc YX. So the black there, that arc would be equal to, let's see, green arc plus blue arc. In other words, the measure of YX plus the measure of XZ. So nothing complicated there. It's exactly the same as segment addition postulate. For homework, they'll give you exactly the same thing. They'll give you a little piece of the arc and ask you, or they'll give you information about the arcs, and then they'll ask you how much is the larger one. Slightly more complicated, maybe, but remember, if you see a diameter, you have 180 degrees. If you see a full circle, which you always will, it's 360 degrees. So you may have to use those two numbers, 180 degrees and 360, to figure out an unknown piece. But it's pretty straightforward. I'm sure you'll do fine with it. So 2 quick examples of what homework would look like. Just make sure you read carefully. I always touch the letters when I'm with my finger to make sure I've got the right arc they want. So they want arc A, B, C. So and it's got to go in that order, A to B to C. So if I follow around that circle, A to B to C, from A to B is 90 degrees. So that would be the measure of arc AB. And then from B to C, it says it's 110. So I'm sure you beat me to the punch here. It's 200 degrees. And remember, arc measure is done in terms of degrees. And the little M's there mean measurement. All right, so that one's very easy. There's always a challenging one. So this isn't horribly challenging, and there's a few ways of doing this. If you want to pause it, try to figure it out on your own. I'll tell you my explanation. Sometimes my explanation is exactly the way other students would do it. Other students find different ways. All right, so let's see. We need to go from B to A to C. So if I go from B to A, that's marked. That's 90 degrees. So B to A, and I need to add that to A to C. So B to A is 90, but A to C is unmarked. So a couple different ways you can think about this one. The way I think about it is, well, there's 2 arc measurements there, 90 and 110. There's 360 degrees in a circle. So if I'm only missing one piece, 90 plus 110 is 200, and 360 minus 200 would give me the remaining piece would be 160. So AC is 160. So toss that back into our original one. 90 plus 160 is 250 degrees. There are other ways of doing this one. That's how I think of it. Okay, last definition. So when arcs are congruent, we have to meet one of two stipulations have to be met, right? Either the arcs have to be in the same circle, or they're arcs of congruent circles. You're going to hear the same verbiage for a couple of days now. We're going to say arcs in the same circle or another congruent circle. It doesn't have to be the same circle, but the circles have to be congruent. So if you're a congruent arc, let's say you're on the same circle like this one, you are congruent if your measurements are the same. Well, clearly AB is equal to CD since they both measure 80 degrees and they're in the same circle. But if we had another circle, right? Notice our circle there on the left has a radius of 6. So any other circle with a radius of 6 whose arc measure is 80 degrees would also be congruent to either AB or CD, right? So, but you got to meet the stipulation that the 2 circles have to be congruent, right? Why would that not work if they weren't congruent? Right, there's the but here. I'll show it to you. Well, let's see. So there's a circle with an arc measure of 80 degrees. Here's another circle with an arc measure of 80 degrees. And you can visibly see that the size of the red and the size of the blue, even though the numbers are the same, those are not the same arcs. One is much physically smaller than the other one, even though technically they both measure 80 degrees. How is that possible? Well, because the two circles are not congruent. One has a radius of 6, one has a radius of 4. Hopefully that made sense. Another point. If we actually play connect the dots between the arcs, so let's say the big circle there on the left, arc AB, if we play connect the dots, we get that chord AB. If we play connect the dots on the arc CD on the one on the right, we get we get a chord CD. And it turns out that it is possible to have congruent chords of different circles. Well, I put a tick mark there, right? But it turns out that if the circle is smaller, the arc measurement ends up being not congruent. The only time that the arc measure will be the same is if the two radii are the same. So even though you can have congruent chords of two different circles, it doesn't mean that the arcs are congruent. It only means that in the case of congruent circles. Tomorrow or next class, we'll talk about what happens when two circles are congruent and the chords are congruent. But I want you to remember that if you have congruent chords, it doesn't necessarily mean the arcs are congruent. Here's a perfect example right here. All right, so lastly, we talked about congruent arcs, and we'll finish up with a theorem. And the theorem says this: when you have congruent circles, so now we're gonna make the stipulation that the circles are congruent. So 9.3 says this: when you have congruent circles, if the arcs are congruent, then the central angles must be congruent. And now this is going to be biconditional. So if the central, now remember this is for congruent circles, if the central angles are congruent, well then the arcs are congruent. Now there's the words of the actual theorem from the book. It says, in the same circle or in congruent circles, if two arcs are congruent, if and only if their central angles are congruent. So this is a biconditional statement, meaning it goes both the normal statement and the converse are both true. I like the one on the bottom there, right? So if the arcs are congruent, central angles are congruent. If the central angle is congruent, the arcs are congruent. Remember, this is for same circle or congruent circles. So that's theorem 9.3. One last thing. On the homework questions number 10 and 11, I really do want you to take a look at it. They're both tables. And I will say this: they are a little challenging. Impress me, see if you can do them. If you can't, I will certainly give you the explanation, but just be careful on number 10. I think number 11, the last column of number 11, they give you no values. They just give you variables. So they just want you to do the math with variables. So you're not going to wind up with the central angle is 80 degrees or something. You might end up with the central angle is equal to the variable h or something like that. So good luck with those. Many times kids run into issues with number 11, especially the last column. No big deal if it is. Just ask me, I'll give you an explanation. All right, that's it. So that was a good week's worth of work. You took a test, you did 3 classes. You have a great weekend, and I will see you again on Monday.